Okay, the next lesson we're gonna do is it's called a paired t-test. So the book calls it testing the difference between the means if your samples are dependent. So dependent means they're related. So it can either be the same person or a pair, and you're comparing one to the other. You can also call it a paired t-test. Okay, so these are going to be the notes. I'll send you a picture. And in this section, you want to know if there's a difference between the two things that you're looking at. Okay, so what we're going to focus on, we don't really care about what's the mean for the first group and the second group. We care to see if there's a difference. So for example, is it easier to lose weight with exercise or diet? So we don't really care how much weight you lost with each one. We want to see if there's a difference. So one week you'll exercise and not diet, another week you'll diet and not exercise, and then you see if there was a difference between the two. So that's the key here. Was there a difference between whatever two things you're looking at? So we're going to find something. This is a new symbol. It's called D bar. And D bar is the mean for the difference. And then we also have the standard deviation. It's going to be S sub D. And again, D is for the difference. So that's the standard deviation of the difference. And the way you write the hypotheses is different than what we have been doing. So let me explain, because that is going to be very different than the last two lessons. So these are your options right here. It's always mu sub D. So you're saying the mean of the difference equals 0, or it doesn't equal 0, it's greater than 0, less than, whichever one. So what students ask is, how do I know which of those three to choose? It depends on the keyword that the problem has. Okay, so these are your keywords. The keywords for the equals, not equals is change, different. So for example, is there a difference in weight loss between diet and exercise? It'd be this. The keywords for, so you notice how this is greater than? The keywords are reduce, lower, lose, so it's the opposite. And then this one is less than, and the keywords are things like increase, gain, improve. So I suggest that you have these notes handy, write them down before you do your problems, so that when you do the problem, you can refer back and say, well, which of the keywords am I using? And then you know which hypothesis to pick. And then the formula, I'll provide you, since you don't have a graphing calculator with you. If we were in class, then I would have you do it in class on the graphing calculator, but we're not and you don't have one. So I'm going to provide you with the standard deviation and the mean of the difference. So these two you'll get, I'll give them to you because you don't have the calculator. This one is always equal to 0. So that's easy. Oh, I wrote it here. So the mean of the difference is always 0. I'll provide you with these two, and then n, you just check how many are in your sample, and that's n. And then degrees of freedom is n minus 1. Okay, so let's look at an example. Okay, so this example is about golf, and it's on page 463, example 1. Okay, if you're not familiar with golf, the lower the score, the better. So just keep that in mind, because typically in most sports, the higher the score, the better, but this one's the opposite. So a company is making new clubs for golf, and they're hoping that they improve the score. So improve the score means it goes down, because the lower it is, the better. So here they gave you a table with the score for each person with the old design and the score with the new design. So remember I said that we want to see if there's a difference. That's the purpose of the lesson. So we don't really care what the score was. We care to see, did the design make a difference? So for example, this person went from an 89 to an 83. So did it make a difference? Yes. What was the difference? Well, 6 points. And then here they give you the table. And this last one, you can ignore it, since I'll be giving you that data. You can ignore the d squared. And then the second person went from an 84 to an 83. So there was a really small difference. It was just a difference of 1. Then the next one, they went from 96 to 4. Okay, and then the other one, see, it's negative. they went from 82 to 84. So their score actually went up. And in golf, that's not your goal. Your goal is to have a lower score. And there was one person where it stayed the same. So we want to know, was there a difference with the design? Okay, so to do the problem, first we have to pick which hypotheses. Okay, so the question says, does the design make a difference? Okay, and we're going to pick the keyword. Actually, sorry, it doesn't say if it makes a difference. It says, is there enough evidence to support the claim of the manufacturer? So we want to, they're saying, that they're claiming that it lowers the score. Okay, so that's the claim. And that would be your keyword. So it does lower the score. It's right here. The manufacturer claims that the golfer lowers the score by using the new design. Okay, so if we go here, we look for lower. So we're going to use, okay, this one here, lower. And that would be here. So we're going to use the null and the alternative. These right here. So I'm going to rewrite them. If you want to put a little phrase just to remind you, because it's the opposite, you could. So this means that the score was lowered if the number is positive. Okay, so for example, it went from 89 to 83. Did it go lower? Yes, and the difference is positive. So that's why we have greater than 0, because those are positive numbers are greater than 0. Less than 0 means, so for example, this number is negative 2. So the score went up. It got higher from 82 to 84. So that's not what we're interested in. We're interested in lower, and lower is this one here. Okay, like I said, if you had your graphing calculator, I would tell you input this in L1 and find the mean and standard deviation, but you don't. So I'm going to provide you with that. So this is a mean of the difference, and this is a standard deviation of the difference, which I'll give you. N is how many golfers do we have in the sample? 8. Okay, so N is 8, and then degrees of freedom is N minus 1, so 7. And then the problem says to use 0.10 for alpha. Now from here, it's the same as the other ones. You write down the formula, you get the values, and you substitute for each one. You get your Desmos calculator, and you get 1.5. Again, since you don't have a graphing calculator, we have to use rejection region. So DF7, alpha is 0.10, and this test is 1 tail. So we go here. We go to 1 tail, 0.10, DF is 7. So 1.415 would be our critical value. So I'll write it here. It's 1.415. Okay, that's where you shade. You see how this points to the right? We shade to the right. And then when you calculate this, you get 1.5. So if this is 1.41, 1.5 is on the right side on the shaded part. So because you shade, the dot is on the shaded part, you reject the null. And the sentence is the same as before. We have enough evidence to reject the null. So if you reject the null, you believe the alternative. So we believe that the new design did lower the score. Okay, so hopefully you understand it. I'll do one more example just in case. If you want to follow along in your book, it's going to be the one on page 465, where it says try it yourself. Okay, so they have a new drug and they want to see if that drug changes a person's body temperature. Okay, so the key word would be changes. And I said that when that's the key word, change, it's going to be this hypothesis. So we're going to write this, the formula, and then put in the values. Okay, so to set it up, you're going to need the average of the average of the difference and the standard deviation of the difference, which I'll provide because it's a lot easier to do with the graphing calculator. And then you see the sample. How many does it have? 7. Okay, so N is 7, degrees of freedom is N minus 1, and that's given. So it says if there's a change. Okay, so that's my null and my alternative. Just a reminder, the null has the word not, so it'd be the drug does not change the body temperature. This would be the drug does change the body temperature. And then you draw the graph. Again, we'll use rejection region. So I'm going to use DF6, 0.05, and 2 tails. So I go here. DF6, 0.05, okay, 2 tails, 0.05, DF is 6, so 2.447. Okay, I'll write it right here. 2.447, and because it's a two-tailed test, it's also negative on the negative side. That's where you shade. Then you get all these values. You put them in the formula in Desmos, and for T you get 1.61. Okay, so if this is 1 and 2, 1.61 is in the middle, a little closer to 2. It falls in the part that's not shaded, so from there I think you know it's failed to reject. And the sentence is, we can reject the null. So we don't have enough evidence to reject the null, so we have to conclude the null, that the drug does not change the body temperature.